Hi guys, welcome to my channel. This is the continuation of the series of videos about differential equations. This time we're going to talk about exact equations, how to solve them, and how to identify them. So first of all, I'm going to say that this type of equations have a general form that we need to identify. And the general form is given by the following. So we should have a function m that depends on x and y plus a function n that depends also on x and y, but this function will be multiplied by y prime and this will be equal to 0. This is the general form for an equation that is exact, but in order for this equation to be exact, we need to satisfy one condition. So the condition is that the partial derivative of m with respect to y must be equal to the partial derivative of n with respect to x. If we have this to be true, then this is an exact equation, and then we can say that there exists a function psi that depends on x and y that will be the solution of our problem. And the solution of our problem will be psi of x and y equal to a constant. So this will be the final solution of our equation. But how to find psi? So in order to find psi, we'll see that psi of the partial derivative of psi with respect to x must be equal to my function m, and the partial derivative of psi with respect to y must be equal to n. So then we have a system of equations, two unknowns, and then we can solve for this. We'll have two unknowns. It's not clear now, but we'll have two unknowns. So we need two equations to solve the system. But again, let's solve this with a problem. Just before going for the problem, the important step is to first check this part, that the partial derivative of y is equal to the partial derivative of n with respect to x. So let's do our first problem. So the first problem will be the following. So let's put example 1. So we'll have the following. We have y cosine of x plus 2x e to the y plus sine of x plus x squared e to the y minus 1 equal to 0. So in this problem, we can say that this part here is equal to m, and this part here, oh, I forgot to put a y prime. So here we need to have a y prime equal to 0. So anyway, so this is just equal to n here, okay? So again, the first step that we need to do is check that the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. So let's see if that's true for this example. So we need m of y equal to n of x. Partial derivative of y equal to the partial derivative of x. So we'll see. So here for this part we'll have cosine of x plus 2x e to the y. Now let's take the partial derivative of n with respect to x. We have cosine of x plus qx ey. Okay, we can see that we have an equality here. So therefore we can say that this is an exact equation. And therefore we can find a function psi that depends on x and y, where this function will be equal to a constant c, and this function will be my solution of my differential equation. But now let's jump to the step where we find the function psi. How do we find psi? So psi is given by these two equations here. So the partial derivative of psi with respect to x must be equal to m. So in other words, we have that the partial derivative of psi with respect to x must be equal to, what is m? So m we have to be equal to y cosine of x plus 2x e to the y. So, and if we solve for this, we'll have that psi is equal to the integral of y cosine of x plus 2x ey dx, because we're integrating with respect to x, it's equal to, so let's do this integration. So this will be equal to y sine of x plus x squared e to the y. And now here is the important part. Here we won't have a constant, we'll have that our next term will be a function that depends on y. And the reason why this is true is because my function psi depends on two variables, x and y. So when I'm doing the integration, then my constant term, not constant in this problem, will be a function that depends on my other variable. So then we have found what the value of our function psi is. But now we have this variable here that we need to find what is equal to. So, and that's when we use the second equation. What is it? We have, oh, I didn't say it, but the second part is that the partial derivative of psi with respect to y must be equal to n. So we can find this. So let's take the partial derivative of this part here. So the partial derivative will be sine of x plus x squared e to the y plus h prime of y. So, and this must be equal to n, but let's see what n is. N, according to our problem, is sine of x. Okay, so it's basically the same, sine of x plus x squared e to the y minus 1. So we can see here that h prime of y must be equal to -1. Okay, so once we have that, we can solve for h of y. We can just integrate here, and we have that h of y is just -y plus c. But, you know, we're not going to care for that constant for now. So we found that h of y is -y, so we can replace that function back to psi. So we'll have that psi of x and y is just equal to y sine of x plus x squared e to the y minus y. And remember that what I said, that this must be equal to a constant c. So I set this in here, and we have found the solution for our differential equation. So again, the steps are simple. First, we verify that the equation is exact by checking that the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Then if that's true, we can say that there exists a function psi that is where this function equal to a constant will be our solution for the differential equation. And the process to find the function psi is just to notice that the partial derivative of psi with respect to x must be equal to m, and the partial derivative of psi with respect to y must be equal to n. And then we can solve. Okay, so let's do another example. Maybe this will clear more ideas. So our second example will be the following. So we'll have, let me put example 2 here. So we'll have 2xy squared plus 2y plus 2x squared y plus 2x y prime equal to 0. Okay, so again, we can say that this part is just equal to m, and this part here is equal to n. And now we need to verify if they're exact. So again, let's go back to see how we verify that they're exact. We need to verify that my is equal to nx. So the partial derivative of m with respect to y must be equal to the partial derivative of n with respect to x. So let's do that. So we'll have 4xy plus 2 must be equal to 4xy plus 2. And we see that we have reached an equality. So we can conclude that this is an exact equation. Therefore, there exists a function psi of x and y that will be equal to a constant c, and this will be our solution of the differential equation. But now we need to find this function. So to find this function, we always say is that the partial derivative of psi with respect to x must be equal to m, and the partial derivative of psi with respect to y must be equal to n. So let's solve for this. So then we'll have this is equal to 2xy squared plus 2y. Okay, so then if we integrate with respect to x, we will get x squared y squared plus 2xy. And here again, instead of having a constant c, we're going to have a function that depends on y. And that's because our psi function depends on two variables, and we're just integrating with respect to x. So therefore, our constant must be a function that depends on the other variable, in this case, y. Okay, so we have found the value of psi xy, but now we have this function here that we need to know what the value is. So in order to do that, we're going to find the partial derivative with respect to y, and this will be just 2x squared y plus 2x plus h prime of y. And this must be equal to our n function according to this part here. So let's see what n is. So n is 2x squared y plus 2x. Okay, so from there we can say that h prime of y is just equal to 0. So then if we integrate this, we know that h of y is just equal to a constant. So then we have our solution. So we can replace this value back into here, and we'll have that psi of x and y will be equal to x squared y squared plus 2xy plus a constant, and I'm gonna say constant 1. And according to the way we define this problem, we say that the solution for the differential equation will be equal to c. So, and I'm gonna say this is equal to c2, so we don't get confused with our constant. So we can do the following. So we can say this is equal to c2 minus c1, but c2 minus c1 is another constant, so that I'm gonna call c. So therefore I have the following. So we have reached to the solution of our problem, and that's all we have to do. There's a special case for exact equation that we're going to cover in the next video, but for now this is all you have to do. And let's go back to again one more time to the steps. So the first step will be to identify the functions m and n, and then we need to check in the first step to if this equation is exact. And how do we do that? We need to check that the partial derivative of m with respect to y must be equal to the partial derivative of n with respect to x. If they're equal, then we can say that there exists a function psi that depends on x and y that is equal to a constant. And we can say that this psi function equal to a constant is the solution of our differential equation. So we covered two examples. I hope they were easy to understand. Hope you follow. And again, thank you for watching. I'll see you in the next video where I'm gonna cover a special case of exact equation, what happens when they're not exact, what can we do, but we're gonna cover that in the next video. Please, if you like the video, please like this video and leave a comment. And if you have any question, please leave questions in the comment. Okay, thank you. See you next.